Assalamu alaikum. Welcome to the Department of Mathematics of GMO Women's College. This is the fourth lecture of the first chapter of SYBSC, functions of several variables. Now, so far we have seen the definitions and properties of limit of functions of several variables. Now we'll see the definition of continuity. Once again, let S be an open subset of Rn and A be any fixed point in S. If f is a function from S to Rm, it's a function, it is a vector valued function. F is continuous at A if this is epsilon delta definition of continuity. If for given epsilon positive, there is some delta positive, such that for given whenever norm of x minus a is less than delta, this implies that norm of f of x minus f of a, in the limits we have taken here L, okay, value of the limit. Now for continuity we have to take this as f of a, value of the function at this point a. If this difference is less than epsilon, then we say that the function f is continuous at a, and we write it as limit of f of x as x tending to a is equal to f of a. So instead of L, if I have here f of a, then the function becomes continuous at this point a. Okay, and if this function is a scalar function, then it means this m is equal to 1. F will be from S to R. Then instead of this norm, it will be here mod of f of x minus f of a. That is the only difference. Okay, so then if f is a scalar function, then mod of f of x minus f of a less than epsilon for norm of x minus a less than delta, then this is continuous function. Okay, so after taking definition of continuity, let us see algebra of continuous functions, which is quite similar to algebra of limit, because in fact we have seen that this is only limit of f of x is equal to f of a. So we will not go into details how to prove algebra of continuity, continuous functions, but let us just go through this. If f and g are any two functions from Rn to Rm, both of them are continuous at some a, then f plus g, f minus g, some lambda into f, lambda f plus mu g, f into g, and f upon g are continuous. For the last function, g should be the denominator, g should not be equal to 0. So all of these are continuous functions at a. Okay, that means actually in limit form we have limit of f plus g is fa plus g of a, limit of f minus g is fa minus g of a, and lambda fx is lambda fa, and this is lambda fa plus mu ga. So in the proof, when we want to prove this using epsilon delta definition, the proof of algebra of limits will be valid, can be used. The only difference is in those proofs, b is the limit of f and c is the limit of g. So in every step, instead of b and c, we can use f of a and g of a, and we had proved that this limit is b plus c, so we will prove this. Okay, so everywhere we have limit of f of a is b, limit of g of a is c. So just we will use, this should be limit of f of x and limit of g of x. So we can just replace f of a and g of a by b and c respectively, and the same proofs can be considered. Okay, so limit of product is product of limits, that will give us this, that f of f into g is also continuous and f upon g is also continuous. Let us come to the problem part of this, and in fact limit and continuity of vector valued and real valued functions we will see in R2, especially in R2 in 2 dimension, and we will see problems in that. So specifically, if we have f from R2 to R, a scalar valued function, then limit of f is equal to L can be here written as limit of fxy, the ordered pair xy is in R2, whenever a point x comma y tends to a comma b. So instead of x tending to a, we are writing here x comma y. So here x comma y is a vector, is tending to a fixed vector a b. Okay. So this is the definition. This will be the limit if whenever given epsilon there is a delta positive such that 0 is strictly less than norm of x minus a, xy minus ab is less than delta, implies mod of this function fxy minus L is less than epsilon, then we say that limit of fxy is equal to L. So this is the simplification of the limit of the function in R2. Now we consider that whenever, this is important, that whenever norm of x comma y minus ab is square root of, we know that this is the norm, this is the distance, is what is square root of ax minus a square plus y minus b square. So we have to remember this. Whenever this is less than delta, it means this term is strictly less than delta, but norm of mod of x minus a, mod of this term, is always less than equal to this whole term, and mod of y minus b is always less than equal to this term. This can be easily proved, it's not difficult. Therefore, whenever this term is less than delta, then these two terms, both of them should be less than delta. So mod of x minus a and mod of y minus b will be less than delta. So in all such problems in R2, whenever I have xy tending to ab, and whenever we have norm of xy minus ab is less than delta, we can directly consider this. Okay. Now, this limit L that we have defined, this limit is known as main limit. Okay, because here we have two other limits also. So this is known as main limit. Then what is the other? Why we denote or we call it as main limit? Because we have the other definitions also that are known as repeated limits or iterated limits. So we define here iterated limits. L1, one of the iterated limits. What is it? Instead of applying limit xy tending to ab, we consider this to be repeated type of limit. If we consider fxy and we apply limit only y tending to b, so when I am taking only y tending to b, I am considering x as a constant, not a variable. So when I apply this limit when y is only tending to b, then actually my answer will be some f of xb, because y is tending to b. Okay, so that will be answer. And on that, now this is only function of x, because we have already taken limit of y is tending to b, so now there is no y term here. So this will change to a function of x, variable x, and b is the constant. Now we can take its usual limit of f of x, okay, as x is tending to a. So this limit will be, after taking this limit, after simplifying this, if I take x limit x tending to a, then this limit is called as first iterated limit. Similarly, we can have other iterated limit, like instead of taking first y tending to b, we can consider limit of fxy as x is tending to a. In that case, y will be constant. So when x is tending to a, it will become some f of ay. Okay, some f of ay. Now we can take limit of y as tending to b. So it will be limit y tending to b this. So this is one by one limits taken with respect to variables. That these two limits are known as iterated limits. Let us see the problems on iterated limits and main limit. First we consider the problem, find iterated and main limit for if exists at 0, 0. Also discuss continuity. Our first question is, this is the question, fxy is xy upon square root of xy plus y square. Whenever xy is not 0 and at 0 at origin, function is 0. It means f at 0, 0 is 0. Okay, so it is given that f at 0, 0 is 0. So see how to solve this problem. We will first solve the iterated limits. So our first iterated limit is limit x tending to a and b both are 0 here. Limit x tending to a means 0 of limit y tending to 0 of f of xy. I'll just substitute value of the function from the given question. So first thing will be, we will apply this limit y tending to 0. Since denominator is not 0, when I take y is equal to 0, this is 0. So this whole denominator is not 0, I can directly substitute the value. So I have x into y is 0 here, and square root of x square plus 0 will become square root of x square. But because of this 0 into x, this whole thing becomes 0. And 0 is a constant whose limit is 0. So the first iterated limit is 0. Come to the second iterated limit. Second iterated limit is limit y tending to 0 of limit x tending to 0 of this. So now I have to take first limit x tending to 0. So limit x tending to 0, when I take here, then this denominator is again non-zero. When only x is 0, this is the square root of denominator is the square root of y square. Okay, and x is 0 here, so this term becomes 0 while taking the first limit, inner limit. Okay, this is 0 and limit of 0 as y tending to 0 will be 0. So the first and second, both the iterated limits are equal to 0. So when both the iterated limits are 0, they are same, they exist and they are same, it suggests us that the main limit of the function may be 0. So we consider now the norm of xy tending to 0, 0. This in main limit we are taking xy tending to 0, 0. So when norm of xy minus 0, 0 is less than delta, then we know that this norm is the square root of x minus 0 square plus y minus 0. This norm is root of x square plus y square is less than delta. Then as I have explained to you that mod of x is less than this term, mod of y is less than equal to this term. Okay, so mod of x will be less than this term, this is less than delta. So mod of x is strictly less than delta. Similarly, this is less than equal to this is less than delta, so mod of y is less than delta. Okay, so to check whether the main limit is 0 or not, so we consider mod of f of x y minus 0, mod of f of x y minus 0 is what? F of x y is xy upon root of x square plus y square minus 0. Okay, will be mod of x into mod of y upon mod of this. This is positive square root, so we don't need to use mod here. Okay, but as I know that mod of y is less than equal to square root of x square plus y square, when I take this to this side, I will get mod of y upon this square root is less than equal to 1. So I can use that over here. Mod of y upon square root of this term is less than equal to 1. Okay, this is clear from this. This upon this is less than equal to 1. So this is less than equal to 1. So this term will be less than equal to mod of x into this term is less than equal to 1. But we know that mod of x is strictly less than delta. It is written over here. Mod of x is strictly less than delta from 1. So I have this is strictly less than delta. So what I can have, my choice can be delta is equal to epsilon. So for given epsilon, there is some delta which is equal to epsilon, such that whenever norm of xy minus 0, 0 is strictly less than delta, then mod of f of xy minus 0 is strictly less than delta. We have shown this. Okay, but this delta is epsilon, so this is strictly less than epsilon. This is the definition of limit. It means whenever xy is tending to 0, 0, this function is tending to 0. So we have proved that the main limit fxy is 0 whenever x comma y is tending to 0, 0. Okay, so this limit exists. So main limit exists, both the iterated limits exist, and they are also 0. And now this is given equal to f of 0, 0. This is given in the question. In the question only it is given. Okay, so all the iterated limits and main limits exist and are equal to 0, and from 2 we conclude that f is continuous at 0, 0, because limit of the function, limit of fxy as xy is tending to 0, 0 is equal to value of the function at this point f at 0, 0. Therefore f is continuous function. because by definition in Rn we know that limit fx as x tending to a is equal to fa. If I have fa, then it is a continuous function. So we have shown this, that limit of xy tending to 0 0 is f at 0 0. So this is a continuous function at 0 0.